This is a question about primitive functions and then a bit of counting. This comes from the entrance exam for engineers, mathematicians and physicists, and you can see this one got correctly answered by 41% of the applicants. So if you want to try for yourself, you can pause the video, read the question and have a go at it. So the question is, suppose that the function f is the primitive function of g, and g of x is x divided by the square root of 1 plus x squared, with f of 0 equals to 2. Then for which n element of n, so the whole number, is the absolute value of n minus f of 10 minimal? So if this is the primitive function of g, to get f we'll need to integrate this. So the integral of x divided by the square root of 1 plus x squared dx, well, you can rewrite dx squared as 2x dx, or you can add any number in here that just disappears with the derivative, so it's the same as d of 1 plus x squared, still 2x dx, or d of 1 plus x squared over 2 is x dx, and that's what we here see, x dx. So we can rewrite that as the integral of 1/2 of d of 1 plus x squared over the root of 1 plus x squared, which is the same thing, so du over root u. So that gives you 1/2 over 2 times the root of 1 plus x squared, plus a constant, obviously. We know that so f on x is the root of 1 plus x squared plus c, and we know that for f is of 0 that should be 2. So 2 is the root of 1 plus 0 plus a constant, so we get 2 is 1 plus c, so c must be 1. So f on x is the square root of 1 plus x squared plus 1. F of 10 is the square root of 1 plus, well, 10 squared, 100 plus 1. So the square root of 101 plus 1. That is almost 11. Not quite, it's a bit more. So this is bigger than 11, but not by much. So this is the closest you can get to 11. So 11 minus f10 will be the minimum, and so 11 is the number n we were looking for.